Well, hello there, ladies and gentlemen. Man, we're going to get on to something new today. We're going to be talking about solving equations that have square roots involved. So, where your variables in the square root. And as always, learning is not a passive activity, but watching videos is. So, if you want to make use of your time while watching this video, you should pause the video, take good notes, all that kind of stuff. Let's get into this now, shall we? Now, here's what we're talking about. We're talking about solving equations that have extraneous solution, or solving equations with square roots, okay? Solving equations with square roots. Now, sometimes these kinds of equations can have what's called an extraneous solution. That's like you do the math and you end up with an answer that doesn't actually work. Um, we're not actually going to get into any of those today, but they do happen. So, what you're going to want to do when you're dealing with these kinds of equations, you want to plug in your answer and check it. We're going to actually get into extraneous solutions in the future, but I thought it'd be a good idea to introduce them now since they do come up in this type of situation frequently. So here's what we've got. Square root of x equals 9. We're going to solve that. Now, if you look at SADMAP, which is the inverse order of operations, right? You do that first. Add, subtract first. Multiply, divide goes second. Exponents go third. And then whatever's in a group goes last. So this one's kind of strange because you see this one over here, 2x plus 3? Well, that's a group. And it's in a group because it's in the square root. It's different than this would be, which is also different than this. Those two are both different. Here the x is in a group, but for a different reason. It's not inside the square root. Here, the x is in the square root, which keeps it in a group. But anyway, uh, exponents. Square roots are actually exponents. If you remember, the square root of 9, for example, is the same as 9 to the power of 1/2. So the inverse of square root is to to raise to the power of 2. Because when you have a power raised to another power, you multiply those and you get 9 to the 1. Right? So that's what we're going to do. But what you do to one side, you've got to do the other. Now, these problems that we're going to be doing now are set up very carefully so they don't use something you don't know how to do yet. But anyway, let's do this right here. So the square root of x squared is x. 9 squared is 81. And that makes sense. Let's check it. That's true, right? If I put my answer, my solution right there, I get the square root of 81 equals 9. That's true. That's good to go. No problem at all. So we don't have an extraneous solution there. Now let's check the other one. So to solve this, we got to get those x's out of the square roots, and the way we do that is we square both sides. When you square a square root, what you're left with is the radicand. It's kind of the special property of square roots. Now, I think it was in the previous lesson, we saw what happens. Might have been 2 lessons ago. Yeah, it was. We saw what happened when you have more than one x and they're separated by the equal sign. You have to get them together. That's your first order of business. So you always want to move the smaller one. So I'm going to go ahead and subtract x from both sides. Yeah? Now, to save myself some time but also still be nice and organized and neat, if I look, I'm going to have my x's on the left of this equation, which means I want all my numbers to be on the right of this equal sign. So I'm going to go ahead and subtract 3 at the same time. That makes just x. Those make 0. These two make 0. And these two make negative 4. So x is negative 4. Now let's check it. Now look, when you're checking, you want to put parentheses because the parentheses keep you from messing up your order of operations. Like for example here, if you didn't write the parentheses, this is what you'd have. That's not what it meant. It doesn't say 2 minus x or 2 plus x, 2 times x. So use your parentheses. So I'd give you negative 8 plus 3 equals the square root of negative 5. Well, that's true. Square root of negative 5 equals the square root of negative 5. They're both imaginary, but it's still true. So, I hope that's been helpful. Man, not too bad, right? Maybe you should try one right here. Let's try one. Let's do 3 equals, ooh, how about this? Let's change that. Let's do 8 equals 4 times the square root of x plus 3. Ooh, be careful. Don't let me trick you here. Go ahead and try it. You done? You ready? Okay, so check this out. When we're looking at the order of operations, SADMAP, exponents go after multiplication and division. This 4, what's it doing to the x plus 3 that's in the square root? Isn't it multiplying? So what we're going to actually do is we're going to actually divide both sides by 4 first. It's outside of the square root. This one was inside the square root, so we could not divide first. But here we can. So that gives us 2 equals the square root of x plus 3. Are you good? Now we're going to square both sides. There we go. X equals 1. Let's see here. 1 plus 3 is 4, that's right. There's something that seems kind of weird to me here. Oh, I see what it is. So let's go ahead and check. So when I plug my 1 in, I get 8 equals 4 times the square root of 4. Well, the square root of 4 is 2. Boom, done. That's true. Dang, got it, bro. Man, I hope this has been helpful. You guys are killing it. Talk to you later.